Okay, this is lesson 1.4. We're talking about patterns and functions. This is some of the terminology that you need to know. A function is a relationship that assigns exactly one output for each input. A function rule is an equation that describes a functional output. This is red. F of x. You're going to need to know this, so you should be writing this down. This is red, f of x, and that is what we call function notation. So if I gave you f of x is 2x minus 6, that's a function rule. Okay? Let me tell you another, and this is so easy, and if you remember this, your life is going to be so easy when it comes to functions. F of x is the same as y. F of x and y are the same. So I could write this. This is what we call function notation. I could also write it this way. These two things are the same. Okay? Function notation. F of x. This is showing x is the input. This would be the output. Okay, input are values that are plugged into a function, and I'm going to write a big fat X next to that. I want to change the color. Input is X. Output is Y. Dependent is Y. Why would they list them this way? Why wouldn't they do X, Y, X, Y, X, Y? Independent is a variable that provides the input, that is X. Dependent is Y. I would not have set the notes up this way. Domain is X and range is Y. Now, let me tell you something. Algebraically speaking, you are going to need to know this. Do you agree that X and Y, that's alphabetical order. X comes before Y. Doesn't domain come before range? Doesn't input come before output? Now, this is the only one that's backwards. Independent doesn't come before dependent. But if you think about input, that's the one that you are putting in. The Y value is dependent on what you put in. The Y, the output is dependent on what you put in. All right. Now, how to write a function rule from a table. First thing you are always going to do is look for a pattern. Look for a pattern. Let's find our change in our table. What's happening on this side? What do you do to 25 to get to 30? You add 5. What do you do to 30 to get 35? You add 5. What do you do to 35 to get 40? Add 5. Now, what's happening over on this side of the table? Adding 1, adding 1, adding 1. What's my rate of change? What is my rate of change? What? My rate of change is, look at this, delta y over delta x. That's the Greek letter delta. That means change in y over change in x. So it's going to be 5 over 1. Now I can even go further. 5 what? 5 minutes per question. Okay? That's what that means. 5 minutes per question. Now, show you two ways to come up with this equation. You've got to find your rate of change, which we know how to do. We've been doing that. Then we need to find the output for an input of 0, and I'm going to show you two ways. Depending on the numbers, the first way I'm going to show you is pretty dark, but it won't always work. Do you guys agree with me? If I started going up this way, what would the next number be? It would be 20. And what would this number be? Does that really make sense for this type of problem? No, because it's not going to, right? But do you guys agree that if we work the table backwards, 20 is the y value or the output for 0 input? Okay? I want you to write this down. This is super important. M is our slope or rate of change. B is our y-intercept. If I do a quick little graph, and I drew a line here, that point right there is what we call the y-intercept. Why do you think I call that point the y-intercept? That's where it crosses the y-axis. So, can I ask you a question? Katrina, what is the ordered pair right there? What's the x value of that y-intercept? 0. We don't know what the y is. We'll use this one, 20. But can I ask you a question? If I put that y-intercept anywhere on the y-axis, what is the x value? Okay. Another way to write this would be f of x equals mx plus b. That's another way to write it. Yes. You could use g of x, t of x, t of x, you can do whatever you want. F of x is usual. But it's always of x. Because x is the input. Now, so, we found our y value for an input of 0 by working backwards in our table. But depending on the numbers that we have in our table, it won't always be handy to do that. That one was easy, right? Super common sense. 0 and 20. They're the next values above where it starts. But let's pretend you can't look at the table and figure it out. Watch what we're going to do. We're going to write down this equation. Y equals mx plus b. M is slope or rate of change. What did we find that to be? Okay, so M is 5. M is 5. You guys follow me? I'm going to pick one ordered pair. I don't care which one you pick. Pick any ordered pair in our table. What is this value right here? This is x. What is this value? Y. And again, you can pick any one you want. I picked that one because I like 3. So, watch what I'm going to do. What is y in this ordered pair? So I'm going to put that into my equation in the y spot. So 35 equals 5, which is m. What's x in this ordered pair? 3 plus, we don't know what b is. We're looking for it. Okay? So I'm going to leave b. This is easy. Easy peasy, lemon squeezy. Can I solve this for b? Yeah. I'm going to have 35 equals 15 plus b. Then what? Subtract 15. So b is 20. That takes a little more work, right? But it works grins and giggles. Let's pretend you decided, I'm going to use these 2 points. So let's do the same exact thing. Y equals mx plus b. What is the red y? 25 equals, what did we find our rate of change to be? 5 times, what is our x? 1 plus b. Am I still going to get 20? Yeah, we can do this all day. We're going to get 20 every time because the y-intercept is 20. The starting value is 20. So, write a function rule. Who thinks they can give us the function rule? What do we find b to be? Plus 20. Yay! Now, that is function rule in function notation. Who can give me another version of that same equation? Ian. Yes, Ian. Y equals 5x plus 20. Yay! Does everybody see that? Yes. Alrighty. Let's look at this one. Now, I'm kind of skipping ahead. Well, I don't know if I want to do that. I know where we're going with this. And, yeah, I'm going to do it. If you look at your definition of function, look at your definition of function. A relationship that assigns exactly one output for each input. So, what's my input on this point right here? 1, what's my output? 2. Now, are there any other 1 inputs? Okay, so 1 input, 1 output. What's my input here? What's my output? What's my input here? 5, 4, 6, 5, 8, 6. La 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 la. You get the idea. Does every input on that graph have 1 output? Yes, it does. And you know, you can tell that. There is a test. It is called the vertical line test. And we're really going to learn about this, I think, tomorrow or the next day. Vertical line test. When you have a graph, if you pass in your little pea brain, this is imaginary, a vertical line. How many times did that vertical line cross this graph? Once. If it only ever passes once, it is a function. Now, let's change this problem up. Let's pretend that this problem was my red dot. Is this a function? No, because what's going to happen? What's my input here? 1, 2. What's my input here? 1, 5. Can I put 1 in and get 2, and then put 1 in and get 5? No, that is not a function. It doesn't make sense. It's not a function. Because a function is, you put something in, you get something out. Put something in, you get something out. This, if I listed these as ordered pairs, this would be 1, 2. This would be 1, 5. I'm telling you, when I was a kid, I always remember for something to be a function, every x value has to be different. All x values have to be different. Write yourself a note. All for something. Well, I should use better terminology. That's terrible. For a relation to be a